Hello and welcome to the first fundamental theorem of calculus. My name is Isaiah and I will be walking you through FTC 1 today. So first off, the fundamental theorem of calculus states that the integral from a to b of f of x dx is equal to f of b minus f of a. And f is the antiderivative of f of x. So using that, we can find that the derivative of an integral from a to x of f of t dt is equal to f of x prime, which is important to not forget the x prime. So g of x, this will often be notated as g of x, setting g of x equal to the derivative of the integral from a to x of f of t dt. So the derivative of g of x is equal to f of t, which allows us to do that. Proving this by doing a longer version would be taking the derivative from 0 to x of 3t squared dt. So that's like taking the derivative of t cubed from 0 to x. So the derivative of x cubed minus 0 is equal to the derivative of x cubed, and taking the derivative of that is 3x squared, which is what we would have gotten had we used the fundamental theorem of calculus. So let's take a couple of examples. In this example, we will take the derivative from 0 to x of t squared dt. So we just plug that x right into the t squared and get x squared times the derivative of x, which is 1. At this point it might seem extraneous, but in other examples it is absolutely necessary to use that derivative as well. So let's do an example where the derivative of x is not extraneous. So taking the derivative from 2 to x cubed of 1 over t dt. You plug the x cubed into t, so it's 1 over x cubed, but then you take the derivative of x cubed as well. So it's 3x squared over x cubed, which is equal to 3 over x. So it changes the answer if you don't take the derivative. So it's absolutely necessary to take the derivative as well. So let's do an example. But what if x is in the a rather than in the b? So the way that you do that, first we have to remember that the integral from a to b of f of x dx is equal to the negative integral from b to a of f of x dx. So using that, we can put x into the b area, and so that's negative derivative of 4 to x of t of square root of t dt. Which will then allow us to do the same thing that we've done in the previous examples and just plug x in and then multiply it by the derivative of x in this case, which is 1. So what do we do? We know how to do if it's in A or B, but what do we do if it's in both A and B? So this example has it both in A and B of the integral. So we have to remember that if you have a function from a to b, the area from a to c, if c is within a and b, plus the area from c to b is equal to the area from a to b. So using that, we can split the integral into two parts. So we take the derivative of sine of x to some c value, so let's set c to 1, of the function, and then add that to 1 to x cubed, which is the other part of the function. So adding those two together will get you the whole area, and then you only have x in one part. So you can easily substitute in and use the fundamental theorem of calculus without losing any part of the function. So the way that you carry this out is then negative 1 to sine x function and 1 to x cubed, so that you can have it in the b part of the function and not lose any parts. And then you multiply again by the derivative of the x area value, and in both of these cases the derivative of x is not just 1, so it's absolutely necessary to take the derivative so that you don't lose that value. So now let's look at some common mistakes people make when carrying out the fundamental theorem of calculus 1. So they will take the derivative of x to something where x is in the a value, and they will just plug x straight into the integral rather than doing the negative part, because that will just get them pos x squared plus 3, but you need to have it in the b area, so you have to do the negative d dx of 5 to x, and then it will get you negative x squared plus 3, um, which is the correct answer, and if you don't do that, you will lose a negative sign that is necessary to get the correct answer. Another common mistake when people are doing the fundamental theorem of calculus is that they don't multiply by the derivative. They just plug it straight in and go, which will also get you an incorrect answer. So for example, if it's 0 to square root of x of t dt, they would just write square root of x, but that will not get you the correct answer. So the right way is square root of x times the derivative of square root of x, which is 1 over square root, 1 half square root of x, and so the answer is 1 half rather than just square root of x. That is a overall summary of the fundamental theorem of calculus. Thank you so much for watching, and if you need any extra practice, I've included a worksheet in the link below and a key to the worksheet. Thank you so much for watching. Bye.